Hi, this is our experiment 5 from RCDCS 143 3B Spin the Spinner. So, for our experiment, we need to spin a spinner that label 1, 2, 3, and 4 for 30 times. And after that, we will record all the 30 results in the table. So, this is 30 result for the spinner in the table. Enjoy!
Experimental probability of the spinner landing on each numbers. So there is 4 outcomes, and for number 1, experiment probability is 10 over 30, which is became 1 over 3. And for number 2, 3 over 30 became 1 over 10, and 4 over 30 became 2 over 15. We simplify all of that, and 4 is 13 over 30. Theoretical probability of the spinner landing on each of the numbers. So the outcome is for number 1, theoretical probability is 1 over 4. And 2, 3, and 4 is the same, 1 over 4, 1 over 4, 1 over 4. Okay, why became like this? Because theoretical probability equal to number of favorable outcomes over number of possible outcomes. Okay. The difference between experimental probability of the spinner stop at 3 and the theoretical probability of the spinner stop at 3. So, probability for experimental probability we get 2 over 15 for because the number 3, the outcomes of 3 we get 2 over 15, and probability of the spinner theoretical probability we get 1 over 4. Okay. To get the difference between experiment probability and theoretical probability, we minus them. 1 over 4 minus 2 over 15. So we get 7 over 60. And we change that to the point number as 0.117. And then to get the percentage of it, we multiply with 100. 0.117 multiply with 100 become 11.7%.
Next, we need to calculate the difference between the experimental probability of the spinner do not stop at number 4 and the theoretical probability of the spinner do not stop at 4. Other meaning of spinner do not stop at 4, it means that the spinners stop at number 1, 2, and 3. So, first, we need to sum up the experimental probability of the spinner stop at number 1, 2, and 3. So, the experimental probability of spinner stop at number 1 is 1 over 3, while spinner stop at number 2 is 1 over 10, and the spinner stop at number 3 is 2 over 15. So when we sum up, we will get 17 over 30. Same goes to theoretical probability. We need to sum up the probability of spinner stop at number 1, 2, and 3. So each of the probability is 1 over 4. So we simply add 1 over 4 plus 1 over 4 and plus another 1 over 4. So we will get 3 over 4. Then we can calculate the difference. So we need to take 3 over 4 minus 17 over 30. Why? Because 3 over 4 is greater than 17 over 30. Otherwise, we'll get a negative result. So when we minus this value, we'll get 11 over 60, or in a decimal point, we'll get 0.183. Then the answer we need to times with 100 because we want in percentage. Then we will get 18.3%.
Next, we need to calculate the difference between the experimental probability of the spinner stop at even number and the theoretical probability of the spinner stop at even number. We just need to use the same concept that we just did just now. So first, we need to sum up the experimental probability of the spinner stop at even number. So since the even number, we only have two numbers, which is number 2 and 4. So we need to sum up both probability for the both number, which is for the spinner stop at number 2, the probability is 1 over 10, while the spinner stop at number 4 is 13 over 30. So when we add both probability, we will get 8 over 15, or in decimal point, we get 0.53. Same goes to theoretical probability. We need to sum up the probability of the spinner stop at number 2 and 4. So we need to add 1 over 4 with 1 over 4, then we'll get 2 over 4, and we can simplify it to 1 over 2, or in a decimal point, we'll get 0.5. Next, we can calculate the difference. So we need to take 8 over 15 minus 1 over 2, because 8 over 15 is greater than 1 over 2. So when we subtract the answer, we'll get 1 over 30, or in a decimal point, we'll get 0.03. Since we need in a percentage, so the answer we need to times with 100, then we will get 3%.
Next, we need to calculate the experimental probability of the spinner not stopping at number 1. The other meaning of the spinner not stopping at number 1, it means that the spinner is stopping at the number 2, 3, and 4. So, we need to sum up all the probability of each number. So, the probability of the spinner stopping at number 2 is 1 over 10, while the spinner stopping at number 3 is 2 over 15, and lastly, the spinner stopping at number 4 is 13 over 30. Then we just add all up and we'll get 2 over 3, or in a decimal point, we'll get 0.667.
Assalamualaikum guys. So here I will help you guys to answer the question for number 2. Okay, so first the question is let y be a continuous random variable with probability distribution. Okay, so here we have two equations here, two functions. Okay, so the first function is y square 0 less than y less than 1, and then the second function is m minus y less than same than y less than 2. Okay guys, so the first question is find the value of m. Okay, so as you guys know, all the probability must equal to 1 here. Okay, so if you want to find the m, we have to integrate these two functions. Okay, so the first function is y square 0 until 1, and then the second equation here is 1 until 2 for the second equation, m minus y. Okay, so after we integrate all this we get m equal to 13 over 6. Okay, so for the next question, we have variance 2y minus 1. Okay, so first we have to distribute this equation first. Okay, so we got 2 square variance y minus variance 1. Okay, so if variance 1 is equal to 0, so we got 4 variance y. Okay, so as you guys know, if we want to find variance, we have the equation for variance. Yes, so variance is equal to mean square minus mean square. Okay, so first we have to find the mean of this function. Okay, so this is how I find the mean of this equation. So we have to when we integrate the function, we have to multiply it by y. So like this, I multiply the first equation by y, and this equation we have to multiply it by y. Okay, so after we integrate, we get mean for y is 7 over 6. Okay, so then we have to find the value for mean y square. So how we got it? Just like the others, yes, we have to integrate it, but this is special because we have to apply it by y square, like here for the first equation and second equation, and we must plus it. Okay, so after we calculate this solution, Okay, so we get 271 over 180. Okay, so for the equation here, so we just put the EY square minus mean y squared. Okay, so we got 4 multiplied by 271 over 180 minus 7 over 6 square. So after we calculate, we got 26 over 45. So that is the answer for the question number 2. Okay guys, thank you.